Printed circuit boards, or PCBs, form the core of all electronic devices. They are found in everything from cell phones to alarm clocks. They form the structural element to which all electronic components are attached, and provide the necessary electrical connections between those components. Prototyping electronics necessitates the quick and easy construction of PCBs, but only a few options are available. The first is to send the design to a fabrication house, which is not very economical and could take days or weeks. The second option is to use current prototyping methods, which leave much to be desired. Among the manual prototyping methods, breadboards are easy to use, but they can quickly become unruly and confusing as the complexity increases. They also cannot be used to build two-scale prototypes. Alternatively, a user could hand solder wires between components on a perf board. However, this is extremely time-consuming and requires considerable skill. Hand-drawn circuits can easily be made being various kinds of conductive ink, but it is hard to make precise connections and complex circuits cannot be constructed. Some conductive inks also have very poor conductivity. Rapid circuit prototyping methods such as milling PCBs or the use of silver inkjet printing is considerably faster, but the upfront costs for equipment and their maintenance makes them inaccessible to a large set of users. We present Printem, a fast, simple, and cost-effective method for fabricating single-layer PCBs. In developing Printem, we were inspired by how Polaroid film and cameras made photography more accessible to everyone by making a self-contained film that produced pictures almost instantly. Similarly, with Printem, users can make a copper PCB with nothing but our specially developed Printem film and an unmodified home office printer with normal ink. To use the Printem film, the user simply places it in the printer. The chosen circuit pattern is printed in negative onto the film using any normal printer. After exposing the film to UV or sunlight for a few minutes, the bottom layer is peeled off, revealing a ready-to-use PCB with copper traces. Printem makes highly conductive single-sided PCBs. We demonstrate several examples that illustrate the various attributes and properties of the Printem film. The first example showcases how Printem can be used to quickly test components. Here, an LED bar graph is easily interfaced with an Arduino. The normally flexible Printem film is glued to a laser-cut board to make it rigid, allowing the Arduino to be mounted on top. This is a paper speaker. Since the sample has been made with a transparent polyamide film, it allows the user to safely solder on it using a low-temperature solder. The copper traces on the flexible Printem film form a coil, and when coupled with a magnet, they form a speaker that generates tunes when a high current signal is passed through it. A curved but rigid shortcut pad is demonstrated here. The device uses capacitive sensing to trigger a specific keyboard shortcut as the various pads are pressed. All of the typography has been generated as part of the circuit pattern itself. After the film is peeled, a stencil is used to apply conductive adhesive to hold the components in place. This device indicates when a plant needs to be watered by blinking a red LED. This sample uses all through-hole components that have been fixed with conductive epoxy. The Printem film for this example has been cut with a pair of scissors into its unique shape. Printem is a self-contained method that allows anyone to quickly, cheaply, and easily make circuits. We believe that all of its various attributes make it highly attractive to everyone from artists and designers to engineers and makers.